Okay, we are on the other side of page 37. Over here, we're going to talk about solving equations. And specifically, we're talking about solving equations that use addition or subtraction. So first, I want you to think of this like a balance. So we have the two sides of the balance, and then we're kind of on that thing. Right, so an equation is saying this thing is the same as this thing. So let's say that we have two squares and two circles, and that is the same thing over here as three. I said squares, those are triangles. I am losing my mind. Okay, two triangles and two circles is the same as three triangles. Well, in order to figure out what a circle is worth, I can take things off the scale, and as long as I take the same thing off on both sides, the scale will stay balanced, right? So if I take one triangle off here and one triangle off here, the scale is still balanced because I did the same thing to both sides. If I take another triangle off here and another triangle off here, the scale is still balanced because I did the same thing to both sides. So now we find out that two circles is the same as one triangle. Or we could say that one circle is the same as half of a triangle. Okay? The important thing we're doing here, one, I want you to notice that equal means the same as. It also would mean the scale is balanced. Secondly, as long as we do the same thing to both sides, the scale will stay balanced. So let's imagine now that we have something like this that says n plus 5 is the same as 10. So I'm still thinking of this in terms of my scale. These two things are balanced. So in order to figure this out, I need to get the variable by itself so that it's the only thing left on this side of the scale. And then whatever is over here is what that's equal to. So I'm going to start by taking 5 off of both sides. I'm going to remove 5. So I'm going to remove the 5 here. And when I take 5 away here, I will have 5 left over, right? Because I took 5 away. Now on this side of the scale, I have just n, and n is balanced with, it's on the other side, it's the same as 10 minus 5 is 5. So n is the same as 5. So we figure this out by, we get the variable by itself. Remember, the variable is the letter. Then whatever is on the other side of the scale when the variable is left over is what the variable is worth. So in this case, n plus 5 equals 10, 5 plus 5 equals 10. N was worth 5 all along. Sometimes, and this is maybe 10% trickier, but really not bad. Sometimes we have something on the scale that looks like x minus 2 is 5. Let's just say. Now, when I want to remove a negative number, in this case, instead of taking stuff off, I can add a weight of 2 to each side. So if this is x minus 2, I can add 2 more to this side and add 2 more to this side. And now I will have the plus 2 will cancel out the minus 2. And I'll just have x over here. And when I do 2 plus 5, I'll have 7. So x is the same as 7, which makes sense because if you do 7 minus 2, you get 5. So we can get the variable by itself by removing the same thing from both sides or adding the same amount. Now, there's a part of this that really stubborn mathematicians have a hard time with, and that is that you must show your work. Having been through all the way up through college calculus, I'm telling you that you're building a habit that you will need in the future. I realize that you can probably do things like this, some of you in your head, and that's great. But you're building the habit of showing your work, because if you don't build it now when the math is easy, you will not be able to add that in when the math gets hard. So you must show your work even if you can do it in your head. So let's do an example of what I mean, because it takes like no extra time. It's very, very straightforward. So if I have, let's say 4 plus m is the same as 11. I need to take away 4 from the m side and take away 4 from the other side, and I end up with m equals 11 minus 4, which is 7. This is what I mean by showing my work. I show what I'm adding or I show what I'm taking away. So this right here is the work that we're showing. Okay, let's do subtraction one. If I do I don't want to do that. K minus 3 equals 20. I need to add the same amount of weight to both sides. And then I will have that K is the same as 23. And that would be correct. So lots to think about there. Probably you're looking at this and like, oh yeah, I know how to do this. And hopefully you're feeling some confidence about that.